Welcome guys to a whole new video, and in this video guys I'm going to show you guys how you can deploy OpenClaw securely on your cloud instance. And the cloud service provider that we'll be using for this demonstration is AWS, where we'll create our own instance and we'll set up a secure SSH tunnel using Twingate, and only authenticated users can access our service running on AWS. We will set up OpenClaw and deploy a bot that we can communicate with OpenClaw using Telegram, and I'll show you guys how you can share the access tokens, how you can connect your bot to OpenClaw and run commands from Telegram. So just a demonstration on how this will work. So if any user wants to connect to our instance via SSH, the user will have to be authenticated in order to access our service. So you can only see only authenticated users can access our service, and in order to authenticate we'll use Twingate, and we'll have to authenticate to our Open SSH resource in order to access our instance via SSH tunnel. So you can see only authenticated users, and we've also added a double layer of two-factor authentication, where we've specified our open client, which is connected to our Twingate connector, can only authenticate once the user is logged in. We'll create separate user groups so that we can assign group policies depending on the resources that we want our users to access. And I'll show you guys how you can set this up on Twingate in order to access your machine and securely SSH into your OpenClaw instance. We'll also set up firewall rules so that any user cannot access our instance, and we restrict connections depending on who we want to access our AWS server. Just to run a test, I'll show you guys how OpenClaw works. And as you can see guys, our OpenClaw instance is connected to our Telegram, and this is how we'll set up our chat channels, and I'll show you guys how you can set all this up on your AWS EC2 instance. So the cloud service provider that we're going to use is AWS, where we'll deploy our EC2 instance. But before doing that, we'll navigate to the network and security option, and we'll create our own security group. We'll create our own security group so that we can define the inbound and the outbound firewall rules that will be directed to our OpenClaw EC2 instance that will be running on AWS. So think of this as a security measure so that you can prevent other EC2 instances running on the same VPC from being contaminated by any traffic that is running on OpenClaw. So if we securely define a security group, we can as well link it to our EC2 instance that will be running on OpenClaw. So for the group, we can give it a name. Then we'll leave it to the same VPC. If you have a different VPC, then you can specify a different VPC. But for this instance, we're going to use the default VPC. Then give it some time to create the security group. Then once it's complete, we'll proceed to deploy our instance, where we'll deploy OpenClaw. So if you want to launch an instance, simply click Launch Instance. Then we can give the instance a name. Then for the base AMI image, for this demonstration, I'm going to use a Debian based image, which is Debian 13. Then for the instance type, depending on the number of resources you want to allocate for your EC2 instance, in my case, I'll give it the T3X large option, which allocates 4 cores for CPU and 16 gigs of RAM memory. Then next, we're going to create a new key pair. And for the encryption type, we'll leave it to the default encryption type, which is RSA. And we'll use the .pem private key file format for SSH connections. So I'll give it a name. You can give it any name. Then once you create a key pair, it will automatically download to your machine. Then on the network settings is where we're going to specify our security group, since we want to isolate the traffic that is coming to our OpenClaw machine, depending on the firewall rules that we'll have created in our case. So we'll select a security group. Then for the storage, you can give it a base storage of around 80 GB. So basically, we've given a name, specified our base image, which is Debian. The architecture is left to the default, which is a 64-bit architecture. Then for the instance type, we selected T3 large, and once everything else is configured, you can proceed to launch the instance. So we'll give it some time to launch and also initiate our instance so that we can SSH into our machine. So right now we have our EC2 instance initialized and the status check is complete. Before we do anything, we'll go back to our security groups and we'll modify our OpenClaw security group so that we can allow SSH connection for the meantime before we modify the rules. So we'll edit the inbound rules and we'll create a new rule that will only allow TCP connection on port 22, which is SSH. then we'll save the rules. So remember guys, we'll come and modify these rules and add other firewall rules so that we can restrict internet connection to our EC2 instance. So once that's done, what we'll do right now is we'll proceed to SSH into our machine using PuTTY. But before we do that, we'll generate a PPK file that we'll use for a connection from PuTTY. So if you guys prefer connecting using the PEM key pair file, you might as well connect via SSH. But if you want to use PuTTY, then the simpler option is using a PPK file. So the tool to use is PuTTygen, and we'll load our key file. Then we'll save the private key without a passphrase. So right now we have our private key file, and what we'll proceed to do is SSH into the machine using PuTTY. So we'll go back to our EC2 instance and we'll select OpenClaw, and in order to SSH we'll specify the public DNS to connect to. Then we'll over to the SSH option, and for the authentication from the credentials option we'll select our private key file. So we'll select accept. The default username is admin. And right now we've SSH'd into our machine. The next thing to do is run an update and an upgrade of our machine. So after running the update and the upgrade, the next step will be setting up our VPN tunnel. And in this case, we're going to use Twingate, which allows you to set up VPN clients so that clients can connect via secure tunnel to your EC2 instance that is running on OpenClaw. So think of this as a security measure that restricts users based on the traffic that they're using, and only authenticated users using the VPN client can connect to our EC2 instance running on OpenClaw. And this is also a security measure because it will also restrict the exposure of our public IPv4 DNS address to the internet. So in that way, we'll restrict the users and also restrict access to our public IPv4 address. And like I said, the VPN that we're going to use is Twingate. So if you're not familiar with Twingate, you can just go to the official website, which is Twingate. Then you can simply register for an account. They give you a free option. So for the registration process, you can simply use your Gmail account.
We'll specify that we use our network for home environment. So depending on what you plan to use with your Twingate VPN network, for this demonstration, we select home environment. Then we select get started. Then you can select any option that suits your scenario. So for this case, I've selected a home lab, and also I've selected an access to a private cloud server that will be running OpenClaw. So simply select continue. Then we'll leave the network name and the network URL to the default settings. Then we'll proceed to sign up with our Google account. Then we'll begin with our first initial setup, which demonstrates how you're going to connect to your network. So basically, what you're going to do is you're going to deploy a connector, which acts as the main VPN server. So our VPN access server will be deployed on the same EC2 instance that is running OpenClaw. So for the deployment method, depending on the base operating system image that you're running on your instance, or in our case, it's a Linux image. So we select Linux. Then we'll proceed to generate our access tokens, which you'll need to authenticate with your account. So the connector basically will be able to handle all remote connections from the devices that will be authenticated from the VPN client that will set up on our end machine. And the base image that we've chosen is Linux. So what we'll do is proceed and copy the command that will launch our connector service on our EC2 instance with the tokens that we've created for our account. And right now our connector is successfully deployed on our EC2 instance, and we can now provide remote access to all the users that will be connecting via the Twingate VPN tunnel. So the next step is to proceed and add our first resource. And for our first resource, we can decide whether to add a host of machines that are available in our local network, or we can proceed to predefine a list of IP addresses that we want to access our instance. So what we'll do is we'll proceed to test with the whole network first, then we'll come and configure the resources later. So for the network, we can choose a subnet, which is subnet 24. Then we'll create a resource. Then the next step is to download Twingate VPN client. So in our case, we are using a Windows machine, so we'll proceed to download the Windows version. And run the installer, which will install Twingate VPN client on our local machine. So in order to configure Twingate, we'll have to restart our machine. So give Twingate some time to reinstall, then we'll restart our machine. Now after the computer restarts, what you're going to do now is set up our Twingate VPN client on our local machine. And it will want you to authenticate using your default account that you created from Twingate. And remember, this account is the account that we use to deploy our connector on our Amazon EC2 instance. So we proceed to join the network. So once you get the authenticated option, it means that our device has been successfully authenticated to our VPN client, and right now we are connected to the Twingate connector on our EC2 instance. So I'll log in back again to verify that our device has been connected to the Twingate connector. So just to confirm, just go to the devices section, and right now you can see that our device is connected to the Twingate connector. Now Twingate has different options for setting up security, and basically you can select and limit the number of users who can access specific resources that are predefined on your Twingate connector. So think of this as a way of defining different policy access to different users who are connected to the VPN network. So in our case, what we want to do is we only want to authenticate the user, Kiso Secure, to connect to our VPN and also to connect to our EC2 instance that is running on Amazon. And we only want to restrict this user and give him only SSH access to the machine so that other users cannot access our machine. If you want to add different users, you can add them as well using the plus option, and you can invite them via email. And you can also specify the groups where each user will be based. So for example, you can create a group of admins and we can set a predefined user lists on the admins group, and these predefined lists will have access to specific resources that are defined on Twingate. So Twingate gives you that option. So let's say, for example, if we want to add ISO Secure as part of our members of the admins group, simply select plus user, then select the user that you want to add. And right now, ISO Secure is an admin member in the admins group. The next step, what we'll do right now is create a resource access. And for the resource access, we can predefine which specific resources we want the specified members to have access to. So as you can see, we have admins and we also have a different group. And remember guys, we've already deployed our connector. And our connector is labeled the home lab network. Right now it's in orange. So just to verify that our connection is successful, we go back to Twingate. And right now we are authenticated from Twingate. Now the next step to do is define the resources. And remember guys, the resources that we want to allocate for our EC2 instance is SSH access. So we want to limit SSH access to the users that are predefined in the Twingate group. So we'll delete this resource that was created initially. Then we'll create a new resource. Remember, our EC2 instance is OpenClaw. Then we can add a label. Then we can specify a domain name. Well, in our case, what we're going to do is we're going to specify a private IPv4 address. Then for this private IPv4 address, we'll set it to the subnet mask 32. Then we're going to restrict the ports that are going to access our machine. So for SSH, we only want to allow port 22, and we'll block all the connections from the other protocols. So we have our private IP address, our port restrictions, and we'll create the resource. So for this resource, like I said before, we are only going to limit it to the users that are in the admin group. And depending on the number of users that you want to grant access to this specific resource, you can update it from the Twingate platform, from the users section. So we proceed to grant access. So right now we have one resource that is allocated to the home lab network with a predefined address. So the next step is to modify the security groups that are handling connections to our OpenClaw EC2 instance. And the first modification that we make, so if you want to modify security groups, you can simply select your instance and select security, then select security groups, and we'll modify the inbound rules. And for this scenario, since we've allowed SSH from any network, we'll proceed to delete this option and we'll save the rules. So right now, any user that is running on any public IP address cannot access our resources via SSH, and we've limited that by predefining the resources and the admin users who can access our EC2 instance running on this specified private IPv4 address. So just to confirm, we check if Twingate is connected. Then we check our devices to confirm that our devices are connected. Go back to the network section. And right now we have one active device, which is our local machine. We have one resource that is online. And we also have one remote network that is online. So we'll delete one of the connectors and we'll only use one connector in our case. Now what you're going to do is you're going to test our SSH connection, and what we'll do is we'll test it first when we are not connected to the Twingate VPN tunnel and see if we can SSH into our machine. So let's do that. So what we'll do is close our connector. Then we'll attempt to SSH into our machine using PuTTY. Remember guys, we've already deleted our SSH connection from the Amazon security groups, so our machine should not allow any SSH connection from any public IPv4 address. So let's try that and see if we can connect. Then go back to SSH, authentication, load our private key. And as you can see guys, we cannot connect to our EC2 instance. Now what we'll do is proceed to turn on our Twingate connector, which is our VPN client. Then we renew the session. Then we'll go back to PuTTY. And this time round, we're going to specify our private IP address that we allocated in our resource section. So this is our private IPv4 address, which we'll specify over here. And we only want to authenticate SSH connection to our private IPv4 address, which has been predefined in our resource section on Twingate. And remember guys, we've already started the connection, and as you can see, we are connected to the connector. So we'll proceed to authenticate using the same private key file. And as you can see guys, we have been authenticated, which means right now we've restricted the users that are using Twingate VPN client to connect to our EC2 instance via SSH based on the predefined list on our admins group from Twingate. So now we're going to proceed and deploy OpenClaw on our cloud server. But before we do that, we're going to create a dedicated user who's going to access the server, and we install CloudBot on the same user. So in order to create a user, I'm going to specify a command that will add a user, and the user you're going to specify is Kiso Secure, which is going to be our user. So we're going to execute it using sudo command. Then we'll specify the password for the user. So let me type the password. The next thing we're going to do is add details of the user, so you can just leave these details to blank. Then type yes. Then we're going to proceed and add Kiso Secure into the sudo as group. The next thing we're going to do is log in into a user. And right now we've logged in into our user Kiso Secure, so we can proceed and install CloudBot on our machine. But just to confirm if the user has sudo privileges, we're going to type sudo who am I to check if Kiso Secure is a root user. So as you can see guys, Kiso Secure is part of the sudoers group, and he has root privileges, so we can proceed and install OpenClaw on our server. So we'll navigate to the official OpenClaw website, which is openclaw.ai. And for this section, we're going to change our command so that we can get a Linux command so that we can install OpenClaw on our server. So we'll click on change. Then we'll specify a Linux command. Then we'll copy this command and paste it on our server. So right now it's installing the latest version of npm, and it's also installing Git and Node.js. So I'll give it some time to complete the installation, then we'll begin with the setup. So let's begin with our setup. We're going to select yes. Then for the onboarding method, we're going to specify that we want the manual option. And for this, we're going to use a local gateway, which will be a local machine as a gateway interface for accessing OpenClaw. Then for the workspace directory, we'll leave it to the default settings. Then for the model, what I'll suggest, if you want a private and secure option, then I'll highly suggest that you use your local LLMs. So it could be data that is coming from Olama, or you can decide to set up a local-based LLM from your NVIDIA DGX Spark hardware. So depending on your preference, if you want a much more private and secure option, then I'll advise that you set up your API keys using a local LLM. In that way, you have all your data that is coming from the LLMs, private, and routed to our OpenClaw instance. So I'll proceed and set up the API keys. If it's OpenAI, you can extract it from platforms OpenAI, and you can simply create a new secret key, then copy the API key and paste it on your CloudBot instance. So for the model, we're going to stick with the current model that is selected, which is a GPT 5.1 codex. Then for the gateway port, we're going to leave it to the default port, which is 18789. Then we're going to set a gateway loopback interface that will roll back to our local instance, and it will run on the IP 127.0.0.1. So for the gateway authorization, what you're going to do is you're going to generate a token that we'll use for authentication to a gateway user interface, where we can access OpenClaw and configure some of the skills and other settings that we're going to see onwards. So select token. Then if you're running Tailscale, remember in our case, what you're doing is you're running a Twingate connector via secure SSH tunnel. But what I would recommend for this option is you select off, even if you're using Tailscale. Then for the token, we're going to generate it later. So for now, we're just going to leave it to blank. Then you're going to configure chat channels. So in our case, the chat channel that we're going to use is Telegram. So we'll go ahead and create a new bot from Telegram that we're going to use as our chat interface with OpenClaw. So we'll select yes. And in our case, what we want to do is configure Telegram bot API. So that's what we'll select. Then for this section, we're going to create a new bot, then copy the bot token and paste it over here. So log into Telegram and create a new bot from bot further. Access Telegram from your Telegram desktop. What I'm using now is the web user interface from Telegram that is logged into my account. And if you want to create a new bot, you can use the command line interface, or you can simply use the user interface that is provided by Telegram. So we select open. Then for this section, you're going to create a new bot. And for the bot name, we'll give it a new name. Then we'll specify the username. You can specify any username that is available. In my case, this is the username that I specified. So the bot is called OpenClaw, and the username is @kisosecure_bot. And what we'll do is we'll select create bot to create the new bot. And what you'll get is the access token for the bot, which we'll copy and paste it on our OpenClaw instance. Then we'll hit enter. And right now you can see, guys, that we've already configured our bot API on Telegram. So the next thing to do is scroll down and select finished. If you want to configure other chat channels, then you can configure them from here, or you might as well configure it from the web user interface provided by CloudBot. But for now, we're only doing it with Telegram. So we'll select finish. Then for the DM access policies, we're going to configure them now. So we'll select yes. Then for the DM policies, we are going to stick with pairing, which is the recommended option. Then for the skills, we're going to jump and skip that. You can configure skills later after the bot is already loaded and can access and chat with you via Telegram. So for now, we're going to skip the skills option. For the hooks, we're going to also skip that as well for now. So for bash shell completion, you're going to select no. Then the next thing you're going to do is you're going to pair and make sure that our gateway interface binds to our loopback interface that we set, which is in the local host. And we're going to try and see if OpenClaw can pair with the bot that we created from Telegram. So what you're going to do is going to go back to Telegram. Then this time what we're going to do is we'll open our bot. And we'll start our bot. So you can use the CLI interface, that is a / then start, or you can as well click on the start button and it will start your bot. Then the other thing you're going to do is you're going to confirm that our gateway binds to the loopback interface and is paired with our Telegram bot. So to do that, we're going to type the command OpenClaw gateway. And you can see it loads the specific model that we've chosen. It also gives the local host address for our loopback interface. And you can see it's already connected to our bot, which we created from Telegram. So what I'll do again is start our bot. And what it will do is it will generate a unique pairing code that we'll use to connect to OpenClaw. So what we'll do is copy this command, then we'll pair with our bot. And just to confirm if everything is okay, we'll test our connection. So OpenDoctor gives us a warning where it says you're supposed to configure our Telegram group policies in the allow list to allow the specific sender IDs that we'll need. So we already have our sender ID, which is this one. And what we'll do is we'll modify the OpenClaw JSON config file using nano editor. So that is nano OpenClaw, then OpenClaw.json. And from here, what we'll look for is the group policy for the allow list. And we can allow from specific sender IDs, or we can also allow from all senders using this option. And just below group policy is where we'll add our configurations, our modifications. And we'll save this file. Then we'll test our connection again from Telegram and confirm if we can connect to OpenClaw. And as you can see, guys, we've successfully connected to our OpenClaw instance. And right now we can communicate to our bot and ask any queries from Telegram.
So guys, there's one thing that we want to fix, where previously we used to manually try and access the gateway service using the command OpenClaw gateway. But this time we want to install the gateway service daemon and run the gateway service from the web user interface. The next thing to do is to install the gateway daemon service, and we'll install it using the force command. So in this case, we won't have to start the gateway service manually, and every time we launch into our instance, the gateway service will be started automatically, and Telegram bot can communicate with our OpenClaw service. So the next thing you're going to do is you're going to enable the linger service, so any user service can run when you're not logged in. So in this case, we have an issue with the bus address that is not defined, and also the system MD user service from the current SSH session is not in the path. So we'll enable linger into our specified user. Then we'll make sure our SSH login has a runtime dir and also a dbus user session. In this case, our xdg runtime is empty, so we'll make sure we set it for this specific section. Now I'll try and start the system user bus and also test the systemctl user just to confirm that everything is okay. And from our prompt here, you can see we're getting the display output that the user works. So the next step is to run OpenClaw Doctor, but in this case, we're going to repair any missing services from OpenClaw. And from OpenClaw Doctor Repair, you can see our gateway service is not running. So what we want to do is install and start our gateway service. So just to confirm, we're going to check our gateway status. And you can see our system MD is enabled and our gateway port is the port 18789. And we're going to run Open Doctor again to verify that our gateway service is installed. And you can see that we don't get an output for installing the gateway service, and our bot is connected to our Telegram instance. So that's it for this video, guys. I've showed you guys how to configure a secure SSH tunnel that is authenticated, and the VPN that we've used for that secure connection is Twingate. I've also showed you guys how we can modify the firewall rules so that we can only authenticate via Twingate VPN connection. I've showed you guys how to create security groups in your Linux environment if you want to create a user group. And for that, you can add a level of authentication so that only authenticated users can access OpenClaw. We've also learned how you can configure your OpenClaw JSON files so that you can only allow messages using the unique Telegram user ID, so that this bot can only communicate with the generated OpenClaw instance with the bot from Telegram. So that's it for this video. If you have any question, guys, please drop it in the comment section, and see you guys in the next one.